Buongiorno, everybody, and welcome. Thank you for taking the time to come here and spend about 1 hour to learn about how to do authentication with Azure Active Directory in your web applications. I trust that you enjoyed the fantastic lunch, and now you're probably about to slide into food coma. So I'll try to keep it a bit lively so that you don't really fall asleep. But unfortunately, the topic is not like holographic stuff. It's not exceptionally exciting. So I'll need your collaboration. You need to try to stay alive. I can't do all the job. Also, for that part of the room, I understand that my appearance is not like freshest. But as soon as I get myself in here, you'll be in a cone of, like my love will not reach you. So if you want to move a bit to see me, fantastic. If you want to hide, by all means, you paid, is your prerogative. My name is Vittorio Bertocci. I am a program manager in the identity team at Microsoft, where I look after the developer libraries and integration with developer tools. So that's what I do. And just for giving you a measure of what we are going to talk today, when we say web app, we actually mean a number of different possible topologies. The most classic is the classic redirect-based application, in which you have something which gets served from a web server, and you render whatever is served in your browser. As soon as you click a link, this link makes a request again on the server side gives you more stuff to render, and so on and so forth to exhaustion. That's the classic web application. But it's most certainly not the only one. Just this morning, some of you had the misfortune of hearing me blubber about native applications calling web assets. In that case, the web API that you consume from native application is also a web application. It just happens not to be consumed by a browser. It gets consumed by a native application. But still, the programming model is similar. And then there is the detail of what happens today, which is far beyond the user simply signing in to the application. I'm sure that you have all had the experience of annoying friends sending you requests for all sorts of odd farm-related topics on Facebook. How many of you guys have a Facebook account? There you go. How many of you ever received an annoying request from a friend? There you go. The technology that enabled that fantastic feat is, again, web APIs. It's Facebook invoking an API, or actually even better, an application invoking the Facebook APIs. And that's the topology which is shown in there, is a web app which calls a web API. And of course, these can also happen from another web API. So you have a mobile app, which is calling a web API, which also calls a web API. And then finally, you also have topologies in which your web browser is not just a passive renderer of whatever gets sent from the server, but it actually contains active logic in form of JavaScript and equivalent, which perform requests in a way which is pretty similar to what happens with mobile applications. That, too, is a valid topology. You might know that under the moniker single-page application, and that, too, has authentication requirements. And the good news is that for all of those, we have something. Like if any of those topologies is something that you are interested into, we have tools that help you to deal with that. And during this presentation, with the exception of the mobile apps, because I had an entire session just a couple of hours ago, I will go and visit what it takes to take advantage of Azure AD from that thing. How many of you guys were in this session this morning? All right, thank you guys. Please accept just a bit of overlap at the beginning. Then we'll diverge, but at the beginning, I do need to have some common part. So here's what I'm going to do. I'm going to cover how to sign in to classic web applications, the ones that I described earlier. And we'll happen to be using OpenID Connect because it's hip and modern, and we are in San Francisco. But in the end, from your point of view, there won't be much of a difference because the tools will abstract away those details. But it's good to know because if you are targeting a platform that does not have such tools, as long as you use a library that supports OpenID Connect, you'll be fine. And here, for each of those topics, I'll describe the high-level pattern, and then I'll talk code. Then I'll describe how you can take your web application and perform a call to an API. This API being a Microsoft API, Office 365, the Microsoft Graph, or your own API. In the end, it doesn't change. There is a pattern associated to that, and I'll expand on that. And finally, if I don't waste too much time, which, as I know myself, I probably will, if I risk not covering it, but I'll do my best to cover it, I'll describe single-page applications and implications from a security perspective, and how to use our libraries to achieve single-page apps which take advantage of all the things that I described earlier. How many of you guys ever used AngularJS? OK, so I must cover that thing. Otherwise, you'll mob me. OK, here is the part where we have a bit of overlap. In the session, I focus on getting a token. I don't do anything very spectacular with this token in this session, because my goal is to help you to understand our object model and use it. And also, my goal is not to sell you Office 365 or all the other things that are associated to it. I'm assuming that during the week, you have been already sold on all of that. How many of you guys went to Office 365 sessions? Very nice. So that stuff is very cool. As you can see here, there are a few numbers, just to impress you, of course. But if you integrate your application with Azure AD, that's the thing that allows you to access all the customers that are already using Office 365. And there is a boatload, like more than 5 million companies are using this thing. And if you want to integrate with any of our APIs, tokens that come from AAD are the currency that you must use. Like without the token, you don't get access. So there is a clear advantage in making this integration. I'm not going, again, to expand on why it's a good thing. I'll just focus on the how. But I just want to make sure that on the back of your head, that thing is clear. Also, I know that it's fun to play with Visual Studio and create your own things. I do that all the time. But relying for authentication on things that don't deliver a number of nines is always very dangerous, because without authentication, there is no user consuming your stuff, and perhaps there is no money at the end of the month. If you look at the numbers that we deal with Azure AD, that's pretty mind-boggling. Like we do 1 billion authentications per day. So if you choose to protect your own APIs, even if you are not calling our own APIs using AD, you are pretty well covered. Let's say that you are using the same infrastructure that we are using for protecting Office 365. So this is my salesman at. OK, now I can go back and show our hands in more architectural topics. Very good. So let's start with the sign-in with OpenID Connect. And let's take a look at how this works. Here, I'll just give you a high-level idea of how it works without going into the details of the protocol. The reason for which I do that is because when everything goes well, you don't need to know anything about this. But as soon as things go south, you do need to have at least a vague idea of what makes this scenario thick, so that you know where to look. So the idea is that you have your browser, you have your web application, and we have one component, which I will explain later what that is. For the time being, is just an interceptor, which lives in front of your web app and is like a watchdog. Every time somebody tries to get the resource, it verifies if the user is authenticated. What does that mean? Say that, oops, in this template I need white. Say that your application performs a classic get. So it tries to do a get of this thing. There is this middleware. We call it middleware because it says in the middle. And intercepts this call and verifies that there is no credential. There is nothing which indicates the identity of a user. Now, what happens is that depending on the protocol that middleware supports, this thing will take in its own configuration and see from where the application wants users to be authenticated from. And clearly here, my sponsor says Microsoft, so we want it to be Azure Active Directory. I'm not going to do introductions to Azure Active Directory. I'm hoping and expecting that you guys already had these in the past. Here, I'll just say that if you didn't have any prior exposure, you can think of these as one instance of a directory in the cloud, with all the things that you would normally expect from a directory: users, application, resources, and the relationships that bind all of these things together. The main thing on top of this is that given that Azure Active Directory is native to the cloud, the ways in which you interact with it are also native to a place where you have to cross boundaries and you cannot rely on infrastructure. So you see all those lollipops. Those are a sampler of protocols that you can use for authenticating users against Azure Active Directory. Just like this morning, I'm putting there SAML and AWS Fed to reassure you that if you have existing investment in that, you can most definitely use it. But given that, again, we are San Francisco and future, we want to use modern stuff. So in this specific scenario, we are going to use the OAuth endpoints. The authorization endpoint and the token endpoint are the endpoints that we use for authenticating with OpenID Connect. So long story short, I try to perform this access. This access is blocked. My OpenID Connect middleware intercepts my call, crafts an authentication message, and sends this authentication message to the authorization endpoint. The authorization endpoint renders authentication UI, so a username and a password, or if you are already authenticated, perhaps multi-factor prompt. Now, every single time I need to do something with my own account in Microsoft, I need to have my phone handy, because my phone rings and I have to put a special PIN. So that thing is part of a UI that appears in that context. And if everything works, then what happens is that the system returns me a token. It's just like a piece of info signed, so that can be used for proving that I successfully authenticated. And then, depending on the flavor of the protocol, this thing gets posted back via auto JavaScript post in here. Now, this time, the middleware sees that there is something that can be used for verifying the identity of a user. And now, this is important. There is one document that AAD publishes called the discovery document, which contains all the instructions to specify how to decide if you like or not like a token. And this thing is basically the list of keys that can be used for signing this token and the identifier of a company that you're talking with. So if I'm talking to the Contoso directory, there will be a GUID which represents Contoso. So if I configured my app to say, I want a token from Contoso, this middleware just in time will reach out, grab the keys that should be used to examine the token, find out what is the GUID to be used for Contoso. It will all be done on HTTPS, validating the server, so I know that I'm getting the info from a trusted resource. And if a token is good, I'll just create a session cookie and send it back. And from this moment on, I'll just be in a pipe authenticated session. You know what? It looks very ugly. I need to make a little more effort. Sorry. Otherwise, you'll tweet that my drawing is terrible. And voila, we have a pipe. Hey, the bar is pretty low with you guys, so excellent. I'm happy. So, and from this moment on, every time you do a request, that cookie will be present and that OpenID Connect thing will intercept it. The reason for which I did this little detour on the discovery part is important, because if you guys did SAML or AWS Federation, in the past, every time a signing key rolled, you had a problem. You would expect hundreds of calls from your customers saying, suddenly this stuff broke. Because in the past, when you'd configure that middleware, you would actually take the key that you found at the moment in which you created the app and save it locally. Instead, with the system that I just described, this thing acquires the token, the signing key on the fly. So you are never broken. Even if we change the key with an emergency procedure, this thing will always self-heal, which is pretty good. Or at least it's been a few years that we don't get those calls, so or they lost our number, or I assume that the system is working. Very good. So the way in which we secure that scenario is by using these OWIN security components. How many of you guys know what OWIN is? Many, but not all. OWIN stands for Open Web Interface for .NET. It is a specification which describes how you can write a software which can process HTTP requests without really knowing where this software is going to run. In the past, you'd do that by writing an HTTP module, for example, which is a component tailored for IIS. So if you do this and then try to run on a different web server, or now with ASP.NET vNext in a different platform, you would be unable to, because that thing is bolted to IIS. Instead, with OWIN, you can write these generic modules, which you can rehost in the cloud. You can have extremely high-density services in which there is no web server, but you just self-host. And long story short, the entire ASP.NET, since already the older version, moved in that direction. And as such, on the identity side of the house, we adopted, and we also offer our support for protocols in form of OWIN middleware. And this thing supports both AWS Federation and OpenID Connect. It's now, at this point, also integrated with Visual Studio. But of course, you might be wondering about Windows Identity Foundation. How many of you guys ever used Windows Identity Foundation? Oh, look at that, fantastic. So Windows Identity Foundation is part of a .NET framework, hence is going to be supported for the next geological era. That thing is there, and you can use it to your heart content, and if you have problems, we'll help you. However, if your problem is I'd like a feature X which you don't have yet, then you might be in dire straits because we support it, but that is no longer our recipient of innovation. Windows Identity Foundation, like it's very close to my heart. I invested years of my life on that thing. It served a great purpose. It ferried the entire industry to claims-based, which is now completely mainstream. However, moving it to the new protocols would have been too difficult. It was too tied to XML. It was too tied to IIS. So we basically took all the good things we learned about that and poured it in OWIN. So long story short, if you want to use Windows Identity Foundation, you are welcome to do so. I can suggest you a book on Amazon. But the recommendation is if you can move to OWIN, all you need is to use .NET 4.5 onward. There are many ways in which you can take advantage of this. If you create a new project with Visual Studio 2013, you can actually create directly a project that supports authentication with AD, but it uses Windows Identity Foundation and WS Fed. If you use Visual Studio 2015 instead, from the RC that we released, actually from the CTP that we also released earlier, we all use OWIN everywhere. So if you create a new project, you will get the new support for OpenID Connect with the new components. Or if you are a real programmer with like Lumberjack t-shirt and similar, you can most definitely use Atom, Sublime, or whatever you like. Just clone stuff from GitHub and use it as a starting point. Personally, I still like the IntelliSense. I'm sorry, I'm lazy. I'll come around. OK, so one thing that I needed to point out is that every time you want to use Azure Active Directory must know about your application. Azure AD will not give a token just to anybody. You need to provision, we like to say, your application in Azure Active Directory so that when you generate your sign-in request, there is an identifier that we know is associated to your app and that we know is OK to issue a token for you. So every time you need to do this step. You can do this step just by going to the portal and creating a new app, or you can use Visual Studio, and behind the scenes, we'll do that on your behalf. So just for giving you a feeling of how this works, here is our beloved Windows Azure portal. We have a tab called Active Directory. Here I have a number of test directories. There is the one I belong to, this Microsoft one, because I am a Microsoft employee. So whatever is your company, you'd find it in there, and that's where your user lives. All the other ones are places where I like to play and do development. And specifically, I like to use developer tenant usually. And here, you have all the list of your applications. And creating a new application is very easy. It's a matter of just clicking add. And here you get asked a few trivialities like the name of your app, which I like to be pretty random. And then you just provide a couple of coordinates like what is the address of your app so that we know where to send the token once we are done. And things like what is the identifier of your app. And I'm not going to create it now, but that's pretty much it. And instead, I'm going to use a Visual Studio for creating it, if I remember my password of this other guy. How many of you downloaded Visual Studio RC? Good job. Oh, no, now you know my password, or at least how long it is. So here is our fantastic Visual Studio. Now, there is one thing that I'm especially happy of this Visual Studio, and it's the following. In this version of Visual Studio, we worked hard to ensure that all the features in Visual Studio that use identity share a common core, a common pattern. So we worked with Visual Studio to have a global cache where all the features can save tokens, so that, for example, in cases like the one that we are going to see, in which I want to create a new app, and Visual Studio itself needs to write in the directory, so it needs my token as a user for performing that operation. In Visual Studio 2013, every feature, Azure, tools, Speed.NET templates, and similar, did these separately. So they all came to me separately, and I had to do 50 meetings. Now, instead, we have one meeting every Thursday morning, in which there is the Visual Studio guy, there is the Office tool guy, there is the Connected Tools guy, there is the Office 365 guy, and we all work and we all use the same stuff. As a result, Visual Studio itself has the list of all the identities that I have. It has all the tokens that I need, and every feature can use it and can, I have to say, collaborate, which is pretty nice. Although I see a couple of yellow thingies that worry me a bit. The demo gods might not be my friends today. So here I'm just creating a classic web application. And as part of this, we already had this in 2013. I have my opportunity of deciding what kind of authentication I want. As you can see in here, I'm asked to specify just a couple of things that are the equivalent of what I would specify on the portal. But simply Visual Studio will take this information and push it on its own automatically. And here there is a drop-down. I don't think I installed Zoom-It. No, I didn't. Sorry. So here I have a drop-down which contains all my Azure Active Directory tenants that I can use. And Visual Studio knows that because, as you have seen in the sign-in page, there were all of my users there already. So Visual Studio automatically reaches out, finds out all my options, and presents them to me here. So very handy. I don't have to figure anything out. And as I said, I want to play with developer tenant. Here I can do things like just do sign in or give it to my app the ability to read my directory. I don't need it now, but I'll need it later. So I'm going to check it. And once I hit OK, and I hit also OK, now, as usual, Visual Studio will download half of the internet in form of nuggets. So it will take a couple of hours to create my project. But at the end of it, it will also grab my token and go to the directory and write an entry for my app so that I don't have to go to the portal myself. Everything is done behind the scenes by this. And I didn't get any error message, which is usually a good sign. And just to give you a feeling of how this works, here I have a file which contains configuration steps that happen at runtime. If you were used to Windows Identity Foundation, you'll be surprised by how more compact this thing is. Windows Identity Foundation kind of made a big sprawl of all the possible parameters. Here, we just take the bare minimum, and if you want these other parameters, you have to dig into the object model. It's still there. It's still accessible, but it's not shoved in your face like we were doing in Windows Identity Foundation. And here, basically, what's happening is we are adding to our own middleware pipeline a component which says, I want to use sessions based on cookies, which is what we have seen in the diagram. I want to keep track of my sessions using cookies, one. And then I add another component in my pipeline, which is this OpenID Connect authentication, which is the component that intercepts unauthenticated calls, generates the sign-in requests. Once it receives tokens, examines it, and if it likes it, tells to the cookie session manager, good, create the cookie, and then validates it afterwards, all of that stuff. And the only things that you need to pass are the identifier of your app, which is assigned when you create this app, and what we call the authority, which is the directory you want. Like, I want users from Contos. So here you'll have Contos. And everything else is unimportant. Now, the reason for which I blubbered is that sometimes it takes a few seconds to propagate. So I gave the backend some time to provision my app. So if you do this yourself, and if you hit F5 and you see a yellow screen of death, don't be alarmed. Just wait another couple of seconds and hit F5 again. All right. So here I have my web application free underscore interesting number, because clearly I already had other web application free in that tenant. I've been using it for the last couple of years, so it's overdue some cleaning. But here I could have given it a decent name. It would have looked better. And here the system sees that I've been using other accounts from this part in the past, so it offers me to pick one. What is my password on this one? I didn't think this demo through. Let's try this one. And voila. That was the right one. If it wouldn't have been the right one, I would have been dead in the water. So what you see in here is what we call a consent page. So I created this application as a developer, but the creator of this application was not an administrator. So this application basically asks to the user if it can perform the things that it wants to perform, in this case, sign in and access the directory in read mode. But it cannot grant this permission. The user must be prompted for it. And now, as a user, I can choose if I trust this application or not. And here, when you hit Show Details, if this would be a real application, you'd see the name of the vendor, so you'd have information for making that decision. So I hit Accept. These things, churns, and of course, you know why this happens, right? This happens because IIS Express, after some time, gets bored and just goes down. So it's not my stuff, it's the stuff that lives under. Just so we are clear when you write your evals. Let's do this again. Do it only if you are in excellent mood after having drunk like a nice coffee. Don't do it while you are grumpy. It's important. Now, actually, we'll have an opportunity to see that given that I already gave consent in the past, now I'm not going to be prompted again. Like now the directory knows that this user gave consent. So from this moment on, I just get my token. And here, I've been signed in. So pretty straightforward. Let me switch back to the demoware. All right. So we have seen how this works, just for reinforcing. You add something which deals with a session. If you want, if you're doing a web API, you don't, as we'll see in short. You add the protocol middleware. And then one thing that we didn't see was that in order to trigger authentication, you needed to specify which resources you want to protect. So this thing is not like a blanket that as soon as you add it, every request is authenticated. You might have areas of your app where you want to have an anonymous experience. Like, for example, if you're selling this application, Typically, the sign up where the user lands and gives you the credit card is not authenticated yet. But then you might want instead to have subsections where you do want authentication. So you use the classic authorize attribute that you use in MVC with any other mechanism like forms of and similar. So not really very mysterious. And this is just for like the most basic scenarios. Then you can do things, of course, like triggering an explicit sign-in. So you don't need to wait for the user to go to a protected resource. You can actually add the capabilities in your system that will trigger a sign-in. The same goes for a sign-out. If you want to sign out, there is a mechanism that allows you to do so. And this is just like the tip of the iceberg. Let's say that, as I said earlier, in Windows Identity Foundation, we gave you many parameters up front. And you could use all those for customizing aspects of authentication. Now, we still have all of those, but they are somewhat in the background rather than in the foreground. So if, for example, you want to manipulate more things, there we have more parameters that you can add. So besides the client ID, besides the authority, you can start specifying where you want to go back after you signed out. Or you might want to take over of a validation of a token. If you are accepting tokens from multiple providers, you can't just read the document that I described, because that document is just for contours. So you need to have some logic which says, don't look at the issuer that you found in the document. I will tell you which issuer I like. And maybe you have a database with a list of all the people all the organizations that bought your service. So it's a very flexible system. The other thing that we have are notifications. If you use the Windows Identity Foundation in the past, you are familiar with events, which we raised as a part of a validation pipeline. Here, in the modern world, we use notifications. In the end, same stuff. And substantially, those things take place at specific moments when you receive your requests. So there is a notification that triggers when you receive a message. Some customers are using these notifications for adding things that we don't support yet. Like there are flavors of OpenID Connect that we don't support out of the box. Using that notification, you can intercept the message and examine it and add whatever logic you want. Or we have notifications which happen just before we validate the token and just after we validate the token. And we have other notifications that take place when you receive a cookie. So if, for example, you want to accept expired cookies up to a certain time, you can add the extra logic. I'm not suggesting you should do it, but just saying that that's possible. And those are all notifications that happens when you receive a request. There is just one but super important notification when the request is emitted. When you receive an unauthenticated request and the middleware creates the authorization message for the AAD endpoint, there are things that you might want to inject in there for influencing the behavior of a service. For example, if for some reason you know that the incoming user comes from a certain on-premises directory, and you want them to go straight to their endpoint instead of having an intermediate page where they type their username and password, the username, and as soon as they hit tab, the system finds out that they are from a certain tenant that needs to go on-prem. If you want to skip all that, you can specify these up front. And it's very easy, very straightforward. Or if you have a cookie which is tracking the username, you can take this username and inject it so that when the user sees the page, this user is already present in there. Or you might want to do things like, I'm doing this in an iframe because I just want to refresh my session. So I don't want to show any UX. OpenID Connect has parameters you can use for specifying that you don't want to show any UI. So that is a very important notification. And we can dig as deep as we want, but I know that what you ate is hard to digest, so don't worry. I will not go through all that list in details. This is just for you when you download the deck to find it as a reference, just to know where stuff is. Never mind about this one. OK, perfect. So that was the sign-in part. Now, let's think for a moment about calling an API. This thing can get, let's say, interesting. So what happens here is that we did the dance that we did earlier. So let's fast forward to when we get our token. We're already using it, and we already got our cookie. So we now have a user authenticated as part of this. Now, the thing that we want to do is somewhat counterintuitive. We have this web application, and in the code behind the web application, we want to call a web API. So how do you do that? The web API, just like your website, expects a token. But you can't reuse the token that you just received, because the tokens are a bit like checks. Like if I write a check for Magnus, of course, I knew you'd appreciate. And then you find it somewhere, and you pick it up and say, oh, wow, a check, fantastic. And you try to cache it. It won't work, because unless you show that it's your actual audience, it won't work. Or vice versa. If I try to pay Magnus for his services with a check with a different name, if he's wise, and in my experience he is, he'll push back saying, dude, thank you, but here it must say Magnus, otherwise I can't accept it. So for tokens are exactly the same for good reasons. You don't want a random website to grab a token and then start pretending to be you and playing it around. So every token has an audience. And so if you want this app to call this web API, this app needs to acquire its own token with audience, the web API. So in the past, this was actually a pretty messy affair. But with OpenID Connect, that's actually pretty straightforward. And I'm a bit worried that the pen is suddenly not visible. OK, good. If the pen stops working, the presentation is over, and you are free to go. But it works, luckily, for me, less for you. So what happens is that in reality, when you use OpenID Connect, you can actually combine two different flows at the same time. You can receive the token that you use for doing sign-in, but at the same time, you can also receive what OAuth calls a authorization code. This is a code which proves that the user consented for this app to access the resource it needs to access. It's like a memo, a note to self. This user did consent for this app to access this resource. So what happens is that once you receive this code, as a part of a sign-in pipeline, you actually grab this code and you redeem it against another endpoint in AD, in your code behind. And what happens is that you get back a number of tokens, which, if you're using ADAL, well, if you're using one of our libraries, I'll give you details in a second, can actually be stored in a persistent cache, given that likely you will need this thing all the time, not just now that I'm signing in. And once I have all these tokens in my cache, then when it comes the moment in which I have to perform my call against my service, I'll just have my library go against this cache. I will ask for a token for that web API, and the system will automatically retrieve the token that I need, which is the green one, and just use it for making the call. Pretty straightforward. Now, the good thing of this is that together with this token, you also get this other token, which is called the refresh token. And the access token that you use for your web API is pretty short-lived. It's short-lived for security purposes because we want the ability to revoke it. And it can't last forever, otherwise we can't revoke it. So the trick that Azure AD uses is to give you, together with your access token, a refresh token. And every time the access token expires, you can use the refresh token, just playing it back, against the same endpoint. And this thing will give me back a new access token if my user is still valid. If a user is no longer valid, then that's when a revocation takes place. Now, this is, once again, one value of using a library for performing all these token requests. All those token requests are perfectly standard. Those are OpenID Connect, they are OAuth. So if you wanted to code against the protocol, I don't judge you. You are free to do so. But it's hard. Let's say that it's not just about the message. It's also about the logic that when you receive this request, needs to retrieve the right access token, see if the access token is expired or not expired. If it's almost expired, find the correct refresh token. Retrieve what are all the parameters that you need to perform the refreshing request, craft it, send it out, and receive the request back, pull it out again, and then perhaps you got also a new refresh token and substitute the current ones with the new fresh one. All these things can be done in your code, but trust me, they are a pain. It's a pain that we already went through by creating our libraries. So if you are on a platform where we have the libraries, your life would be so much easier if you use them. And in fact, I encourage you to do so. But I just want to make sure that you don't walk out thinking that you must use the libraries. You don't. Today, we don't have anything at all on Python. So if you want to do this on Python, and you come and you ask me how to do it, I'll point you to the specification of OpenID Connect, because we don't have a library. And you can do it, but it's going to be a bit more painful. Eventually, we're going to support Python as well. OK. So this is a bit more at the code level. So here there is something that I needed to add to the thing that I said earlier, which is I said that Azure AD will not give you a token unless it knows your app. That's also true when you are asking for a token for a resource that your app needs to access in itself. So it's one level removed. You needed to declare in advance what are the things that you want your app to be able to do, so that when I get that consent screen that you have seen earlier, AAD knows how to show that, how to render the list of permissions. And if you don't do that, and then later you try to access a resource you did not declare, this thing will not work. So I'm pointing this out because it's one of the things that tended to be an issue. And yes, let's do this. So let me go back to the other thing. Yep. So here we have one of the famous notifications that I mentioned earlier, which is the notification authorization code received. So if I just want to do sign in, I can ignore this notification. But if I want to do sign in and call an API, then I must actually support it. And in this case, I receive my notification, and what I do is we use our Azure Active Directory Authentication Library, also known as ADAL, to perform the redemption of this code. And I won't go much into the details of this one, and I understand that it looks a bit scary. But I assure you, if you dare to write the protocol code, that would be much worse. Code is still running? Good. So what happens here is that I'm notified in my pipeline. I got a code. So here what we do is we create I'd say a representation of my directory in my code. It's a pointer to my directory. And it's contoso in our case. And as part of this, I actually inject a custom persistent cache, a place where I say, dear application, if you happen to get a token, save it here. And in this case, it's an entity framework-based cache. But you can have any flavor you like. If you like Redis, you can have a Redis cache. If you like table storage, you can have table storage cache. If you want to save stuff in Amazon, you can also do it. It doesn't matter. You can just write your class, and this plugs nicely. And then after you have done that, you just ask to the directory to give you a token through an authorization code. And you pass this code, you pass the credentials of your app. Your app is a website, so it has its own credentials. Can be a certificate, can be a string. In this case, it's a string. Visual Studio created all these for me, so that's why you didn't see anything happening. And so if I execute this thing again, and I put a breakpoint here, I won't, because you'll just see this thing going through this. It doesn't add much. But you'll see that at sign-in time, I actually acquire this token. And then I put this token in my cache. Then later on, I have a controller, which is used for querying the graph APIs, which is the way in which you can query the directory. And this thing will use this token, but we'll use it using the pattern that we like. Specifically, here I have my controller that triggers when somebody clicks on my show me information about the user. And this thing does something pretty straightforward. It recreates the same moniker that points to my directory. So let me pull it out in here, in which, again, I retrieve a reference to the same cache. And then here, I just ask for a token, saying, please cache, I need a token for that API. Given that I just got one, within 1 hour, every time I make this call, I will get back an access token. The same access token I got, it's still valid. So I don't need to worry about where it is, if it's expired or not. It will just work. After 1 hour has passed, when I make this request, the system will find the refresh token and automatically use this refresh token for getting a new access token. And the refresh token out of the box lasts for 14 days. But every time you use it, you get back a new access token and a new refresh token, which has been shifted by the time since you called it last. And again, it will last 14 days from the moment in which it got issued. And this thing today can slide all the way to 90 days. So in theory, once you have this thing in your belly, you can just keep it in there and keep using it for 90 days. We are thinking about making this policy more configurable. Like some customers would like to have these forever. And as long as it's their choice, personally, I have nothing against it. So we'll probably add this feature. But for the time being, it's 90 days. Now, one important thing to take into account is those 90 days might disappear right away if, for example, the user changes password. As soon as the user changes password, all the refresh tokens are no longer accepted. Or if the administrator removes consent to the application, then the application is no longer allowed to do that, so it won't work. Or if the user disappears from the directory. User caught stealing and cheating, thrown out of the company, everything revoked. Or user gets a better opportunity at a different company, same. Just want to make sure I balance the negative scenario with the good scenario. But anyway, without further ado, let me hit play. This thing will do exactly the same thing that it did earlier. Slowly, slowly. Here I want to be an admin. Oops. Now, one of the interesting things of all these is that the moment in which you have tokens, refresh token for one API, so once I click in here, the code behind it I've shown you reaches out, uses that token that I had in my cache to call the graph and get this information. Now, if I'd want to call another API still protected by Contoso, I'd be able to reuse exactly the same refresh token to get a new access token for the new API, which is something that normally in classic vanilla OAuth doesn't happen. It happens in Azure Active Directory because we treat these a bit like a Kerberos ticket granting ticket. Like, I see some gray hair, so some of you guys might remember Kerberos. How many of you remember Kerberos? Hey, look at that. Excellent. So the idea is the same. So also in this case, pretty straightforward. So let me switch back to slideware. And there are other ways of making calls. These calls take place in the context of a user identity. But if you want your app to act as itself, say that you have like a continuous integration thing, you might actually give credentials to this app and act as itself instead of a user. And on behalf of is too long. OK, what I used for querying the directory is the Graph API. How many of you guys know about the Graph API? Few. OK. In classic on-premises Active Directory, you query the directory using LDAP. LDAP is a pretty, it's a very powerful protocol, but it's old. as in it requires user credentials as opposed to tokens, and it doesn't really have much granularity, as in if I want one user to only be able to read and another to read and write, it's kind of difficult to achieve that in a disconnected fashion when you use LDAP. So when we moved Azure Active Directory and reimagined it to use it in the cloud for cloud workloads, we added this new way of querying the directory, which is based on REST APIs. So you just use REST. We are leveraging OData, so we have lots of interesting filtering features and similar, and that's what you use for making all your calls. And the advantage is that we reuse exactly the same auth endpoint and flows, which I've just shown when you go against any directory. So all pretty straightforward. And when you craft URLs by hand, like when you do your calls, you can do things by hand and craft the URIs of your references, or you can use a library. Personally, I like to craft stuff by hand because I don't need to worry about which version and similar. But I know that others like libraries, so up to you. But just for you to judge how this works, you have the first part which says, I want to talk to the graph. The second part is the tenant. Like there is one graph for Contoso and one graph for Fabricam, and the two don't meet. They are nicely isolated. And then there is the entity that you want. You can have users, you can have groups, you can have applications, you can have roles, number of things. And then there is super important, the version of the API that you are using. Different versions have different features, and sometimes breaking changes. So it's important to specify the correct one. And then finally, there is the OData part. So that if there are things that you want to filter on, like reduce the number of elements that come, or just like 0 on one specific area that you want to access, then that's what you use. And for the sake of speed, I am going to skip protecting your own web APIs, because it's pretty simple. You know what? I had a change of mind. I'm going to cover it. I apologize. So what you have seen right now was protecting your website. Your website is using, in this case, a redirect-based protocol, which means that the pattern is I land in there, I do something, I get back HTML, I click something else, I do another round trip, and my interaction evolves in this way. And this is pretty well suited to use cookies for keeping track of sessions. Now, when instead you are doing a web API that can be consumed by clients that are not browsers, so it's not that like you sign in and then you just go about it. Yeah, this is a client which makes a very deliberate call to that endpoint, and then just afterwards can call a completely different endpoint from a completely different domain. So there is really no common structure, and there is no automation like in the browser that says, you're calling this domain, here there is a cookie. Here you're making the calls by hand. So what happens is that your API is expected to present tokens in a different way, in a different format. Auth specifies that you want to create a header and put the token in this header. And every single time you send the token. It's not like you send, then you get the cookie, and then you go. You just send it every time. So we have a middleware that lives on the service side that does not use the cookies, searches for this token in the header of a request, and does the same validations that I described earlier. And using it is very, very simple. Instead of saying using OpenID Connect, you say use Windows Azure and auth bearer is like the longest method we have in the entire framework. But it's the same semantic. Like you specify, you offer your client ID, you specify your tenant, and that's it. So I just wanted to give you like the basics. OK, so now let's talk for a moment about single pages applications. Single pages applications are an interesting animal. The idea is that you have this component on the server side, which sends you back some JavaScript and some HTML. And that is in theory, in practice, it might not be the case, but it's the only page that you ever have. And from this moment on, all the interactions happens because the JavaScript performs calls to your web API on your backend. So you download all these, and it's just like downloading a native client that lives in the browser. And then this thing keeps making calls. Now, this thing is not very well suited for cookie management, cookie work, because, again, when you're calling an API, you might be calling my own backend, but later I might be calling a different backend. So cookies are tied to a domain, and so they would not go to the other domain. The other problem is that when cookie expires, the browser doesn't know what to do. Whereas when we are using a protocol that uses tokens, we can be explicit about handling expiration, renewal, and stuff like that. So what happens is that here we protect the web API using the middleware that I just described. And then we deploy in your web app, in your JS, one library, which is called ADAL.js, which actually helps you to obtain a token and attach a token every time you try to access your backend automatically. And this thing has its own token cache, which can be in the session, or it can be local storage, just like you would do in HTML5 apps. And the idea is that when you authenticate to your endpoints, actually, it's not this one, but it's the authorization endpoint. You do so using one protocol which we call the implicit grant of auth. It's a grant which returns the token in the query string. So we can intercept it from a JavaScript, and we can actually save it in our cache, just like we were doing earlier. So here we have our access token. We don't get the refresh token in here, because I need to say the native clients for JS are not designed to work that way. So what happens instead is that we have an iframe somewhere, which we can use for verifying if you still have cookies, not with your app, but with AAD. And so when we needed to have a new access token, we just use this iframe for renewing this access token. We repeat the call using this iframe, and this call, given that you have your cookie for AAD, can succeed without showing any UX. So long story short, you can just use this thing out of the box, and it automatically obtains tokens for you. It automatically attaches the tokens when you are making the call to the web API, and it automatically renews the tokens that are about to expire. And just to give you a very quick feeling of that, here you have one example of configuring an AngularJS app with this capability. Just like we saw for the middleware, you have one element that you use for injecting which directory you want to use, what is the identifier of your app. On the service side, you have the OWIN middleware for protecting your web API so that it enforces that you call the correct token. And then if you know a bit of Angular, you know that we have routes. And we added one custom element which can say this route must be protected. So when you click on it, this thing will ensure that you have a token in your belt. And let's just give it a super quick spin. Of course, you can also have the sign-in part. So here I have a very simple JS app. If I hit login, I get bounced to the right place. I want to be Mario today. Come on, Mario, sign in. No? Maybe. And voila. So at this point, if I hit F12, then if you are familiar with the Chrome developer tools, and you just go in your session storage, or like actually in this case, the local storage, here you have our ADAL.js database, which maintains all the tokens that you need for calling your web API. And then if I do call my web API, which happens, for example, when I call this to-do list, behind the scenes, the system sees that I'm going where I'm going, retrieves the token from here, attaches it just before making the call, so that the server can receive the tokens it needs. So long story short, even if you wanted to use single-page apps with AD, is very easy to do so. And in fact, blah, blah, blah. I hope that through the session, you had the opportunity to see that that's actually accurate. Let's say that we have seen all the various topologies that you can use, traditional web apps, web app calling an API, and single page app calling an API as well. And all of those things are based on open standards. And even if you